I want to look at discussing how we would go about calculating the enthalpy of a particular reaction. And what we're going to look at today is the following. I don't have the equation written, but we're dissolving ammonium nitrate in water. So it's ammonium nitrate solid converting to ammonium ion in nitrate ion in aqueous solution. And we're taking 3.88 grams of the solid ammonium nitrate and we're dissolving it in 60.0 grams of water. And when we do that, we find that the temperature changes from 23.0 degrees to start to 18.4 degrees when we finish. And what we want to find is the delta H for this reaction. In order to do that, we need to have some definitions of what we're talking about. And I want to look at those definitions. In particular, I want to look at what we mean when we're talking about delta H of a reaction. And when we're talking about the delta H, the enthalpy change of a reaction, we're looking at the heat change in the reaction per mole. So Q of the reaction per mole. So the equation that we're going to use to find the value of Q is this one, where we look at the mass and the change in temperature times the specific heat of the solution. But we need to be very careful here, because we always need to remember that the Q value that we measure for any experiment we do is not the Q of the reaction, it's the Q of the solution that that reaction is dissolved in. And the reaction is going to have the opposite sign. Any heat that the solution gains came away from the reaction. Any heat that the solution loses went into the reaction. So the sign of what we are looking for is the opposite of the sign that we measure. So if we look at the values that we're going to fill into this equation, our delta T is the final temperature minus the initial, or 18.4 minus 23.0, to give us a delta T of minus 4.6. The mass that we're looking at here is the mass of the water plus the stuff dissolved in the water. The total weight of the whole solution is going to be 63.9 grams. And actually, this is a mistake. There should be a plus sign here. So let me put in the plus sign. 60.0 grams plus 3.88 grams equals 63.9 grams. And the specific heat of the solution is going to be the 4.18 joules per gram degree Celsius. It's essentially the same as pure water. When we do these calculations, we find that the Q for the solution is 1200 joules, but we need to remember that the Q for our reaction is the opposite of that, which gives us a value of minus 1200 joules. Well, when we look at what we're trying to find, delta H, we also need to know the moles that we're talking about, the moles of reaction. In this case, 3.88 grams of solid ammonium nitrate. We need to convert that to moles. So 3.88 grams times 1 mole per 80 grams gives us 0.0485 moles. When we fill that into our expression for delta H, a negative 1200 joules divided by the number of moles we have gives us 25,000 joules per mole, or if we convert it to a more manageable unit, kilojoules, it comes out to be 25 kilojoules per mole.